Hi, this is our final project for the mathematics subject given by the teacher Natalia Parra Perez. The topic of this project is the application of the linear function in real life, in which we decide to represent it with the inclination of a plane in its ascent. This project was done by Carolina del Sol de la O de la Rosa, Diana Domínguez García, María Fernanda Martínez Godet, María José Rojo Márquez, and Paulina Montserrat García González. From third semester, section B of the Universidad Autónoma de La Laguna.
In this project, we're gonna show the inclination of an airplane when it's taking off with the application of linear function. Our main objective is that people in general can learn and distinguish linear functions in everyday life. In this case, as I mentioned, with the example of an airplane taking off, obtaining the localized points, the slope of an angle of inclination, the equation in the slope point form, slope ordered at the origin and in the general form, as well as the substitution of values in x to obtain y. A linear function is a simple function usually composed of constants and simple variables without exponents, as in the example y equal mx plus b, and the graph of linear function has straight lines.
For this model, we drew a Cartesian plane at the base where we marked the coordinates of the takeoff of the plane and the coordinates where it already took off. Since we have indicated our coordinates, we can solve the following problems.
We want to know where inclination an airplane makes from its climb point to the point that it is in the air, because it is said that the straighter the takeoff inclination, the better oxygenation in flight. We also want to know the equation of the line represented below.
To know the angle of inclination, it is necessary to first know the slope. The formula of the slope is m equals y2 minus y1 divided x2 minus x1. Now we replace the values with those of the coordinates already given. So it's 5 minus open parentheses minus 6 close parentheses and divided minus open parentheses minus 4 close parentheses equals 11/6. The formula for the angle is tan minus 1m. So tan minus 1, 11/6, give us your angle that equals to 61.389.
Now we will use the equations of the line that represent the takeoff. Slope point. The formula for the slope point is y minus y1 equals m open parenthesis x minus x1 close parenthesis. Now we replace the values with those of the given coordinates. Only the values change from negative to positive, and that's all we have our slope point result. Slope ordered at the origin. The formula for this one is y equal mx plus b. What it will be y equals 11/6 x plus 4/3.
And finally, we will use the general form. The formula for this is y minus y1 equals m open parenthesis x minus x1 close parenthesis. We first do the procedure that we already know, and then we are going to multiply the slope by the values inside the parentheses. The data from the y side will be passed to the other side. Since we have all the additions or subtractions, in case there are fractions, we are going to change them to whole numbers, which equals to 11x minus 6y plus 80 equals 0. And this is how we get our result with the general form.
Now we are going to substitute the values of y, which will confirm that our results are correct. We need to use the result it gave us on the ordered slope at the origin. We need to use the result it gave us on the ordered slope at the origin. From substitute the values of x and y, let's use those at the plane take off the point, and the one from when it took off. In this case, we will replace the x and y with minus 4 and 6, and with 2 and 5. When it's solving the operation with the values already substituted, it must give us the value of y.
This project helps us to learn, understand, and distinguish the different ways in which we can analyze the application of linear functions with the topics seen in class, such as slope of a line and its interpretation, angle of inclination and slope from point, slope of the rate at the origin, and with the general form. This final project led us to the conclusion of how everyday activities can be applied with mathematical problems, and we can realize that it's very easy to find many of them. These kind of problems involve lots of reasoning, but using the different forms we can improve and it's a good way to practice.